Okay, so first we discuss about what is an entity. What is an entity? It's something that we are going to organize, right? So you are the level of an entity, right? So you are an entity. Then I realized that a group of these entities represent kind of student, something. It's called the entity set. So that's what we are going to find in this model. So if we can find such a group of the data, group of entity, that will be eventually something structure that we are going to manage, because all these entities represent the student information. It is kind of organized, related information. That is the data, and that will be eventually table in our database system. Okay, so as we discussed before, from now on, the entity set, entity are interchangeably used. However, you should know the difference between the entities. So first, in real life system, in this example, in the classroom, mostly, we can directly find entity set, entity, student, instructor, okay, or something, the step, teaching, course. You can easily find such entities. But however, real life system, so if your customer just give the bunch of files, then please make the database model for company or for my department. By analyzing, by taking a look at all the file, you should be able to find this is the department, the HR department. This is the payroll department. This is something other department, and this side, this is the department entity type. So that is the first thing that we are going to do. So from now on, throughout the semester, we are going to use two very simple and very well-known database. One is a university database, another one is the company database. The first example is a company database. So that are described in the handout. So you are also very familiar with such a description. Last class we found what? The entity type, entity first. So that is still here. So department and project and employee and dependent. Okay? Somebody may be curious. Why not company? Company, one entity. Also, it may be entity set. However, our goal of this modeling is what? From a bunch of information, we'd like to find the related, important, and organize the data information. Okay? Company is just one. So it's a database for the ABC company. It's not changing. However, if you have a bunch of information about so for example, I have a group of company A, company B, company C, company D. So at that time, you can make the company entity. It can be very flexible, but that's your job to decide whether this will be the entity. This will be, later we will see attribute. Okay? So this is the first suggestion. So there might be a bunch of different ways. There's no general answer, but we try to standardize such an answer. Okay, so first thing is to design the entity type. In other words, it's an entity. We found it. However, we decide to use the diagram. That diagram is to make us easy to understand such our model. That's a rectangle. So from now on, we are going to use the rectangle to represent entity type. The next step is, after we identify this one, we can find first, what is a department? Can you understand what is a department? Because you already know what is a department, but that's your definition, that's the perception. But our database modeling should be based on the requirement or customer request. Okay, so how is department described in this requirement? Each department has a name and also number and also manager, right? Manager. And we keep track of the start of the date of the department. And department may have several locations. Okay? And department may, yes, these are the description of what? Department. I know. In general, department has a bunch of other information. The number of employees and detailed room number and how many the desks are there and the specific, but based on the customer requirement, we can find such a, these are attributes. So next step, after we identify the entity or entity type, the next step is the attribute. As many as possible from the requirement that describe the entity. So in this case, we have a name, number, manager of that department, start date of the manager, and the locations. And these are called attribute. Also, we are going to use not circle over, because sometimes it's wrong, over, then connect to the corresponding entity. Okay? We can do the same thing for the next one, project. Project, each department has a project, each department has a unique what? Name and unique number and location. Same thing, connect to this one. Why don't you do the same thing for employee? Why don't you bring the scratch paper, and this is your first the practice to design the database using ER model. This is an ER model. Don't forget, this is not the database model. This is a data model, conceptual model, and high-level model. Why don't you bring the sketch paper, then complete the next step, two entities. Entities, the attribute. Okay? This is, I know, because you are so smart that you understand everything that I explain, but that's different from what you can do. Okay? In computer science, please, even though you understand everything, try to yourself. Okay? Otherwise, in the exam, many of the students really fail to answer. You believe that you know everything, but in real practice, it's different. So why don't you bring the sketch paper and try to complete the next step and next step. Any volunteer? Anyone? I will give the extra point. It will be added to the final exam. I love to give the chance for the extra credit, but the last few semesters I couldn't do that because I have so many students. There are 60, 70 students, so there is no chance, but this is good. Only for employees, only. Whether or not it's correct, I will give you the extra point. So your name is Paul, right? So if you are very serious for your final grade, so why don't you try to use such opportunity to get the extra point? It will be added to your final grade, not final exam, which means it's huge. Because of point 1, point 2, some of the students got A minus, some of the students can get the A, so no way to upgrade in that case. But if you have extra credit, you will be able to get a better grade. One question. We have a name in department, also name in project. Any problem? Technically, no problem. The name on department is the...
Do you have one?
No, I don't have. So you can download and print out from the press website. So name on the department is the department name. Okay? Name on the project entity is the project name. However, it's also a good idea. So there's no problem technically, but I suggest to use the proper name that can represent the meaning of that attribute. Okay? For example, if the name is custom name, custom CUST name or something like that. First name or F name or last name, L name or last name, so proper name. Okay? So there is no strict rule in database design. There's no strict naming rule. However, depending on your project manager, sometimes your project manager provide the naming rule for your project. So for example, when I worked for the bank, so we have very strict the naming rule. So first of all is the department. Like the accounting department is ACCT. Any table related to the accounting start with the ACCT. Underbar, then specific name. And if it is hard, it should be the 1, 2 numbering, something like that. Column is the same. Okay. Also, you may I will explain later again the more details of the naming rule. The database design, database object are not case sensitive. Anything not case sensitive, but intentionally we can use the lower letter and the capital letter to clarify the meaning of that. Okay, so let's see. The employee. So we can just list out social security number. Where's the social security number? And the address here, salary, sex, and the birthday. What is this one?
Projects, like an employee can be related to a project, so you need to specify.
So you can put, right? And also number of hours per week. It may be confusing, right? Because the number of hours is per project, per employee. But at this time, we cannot represent clearly, right? So that is one of the issues that we need to address later. So let's mark. Okay. Also, this project should be related to this project. And what about the department name? Yes, employee has a department, but should be related to this one. So it's also a good idea to list up all the information, then mark whether some of the attributes are related to other. We will take care later, such an attribute. And director, supervisor of this one. It's also, who is the director? That director also employee, right? The supervisor is also employee. So we need to take care of such a thing. So pretty much okay for the attribute. What about the dependent? Dependent is a similar thing. So we have each dependent, we keep track of name and sex and DOB and relationship. So this is the up to second step. So first step, find the entity. Second step, find the attribute of that. In real life case, this will be like this one. So we have for example, I found the entity of something. We don't know what is it. And also we found we have found so entity. Then we realize is the group of entity of employee. Okay. Then this is the name. This is the address. This is the salary. So this will be attribute of this one. This is more the real life example. No customer, there is no customer who are so generous like this one. Nobody provides such a detailed and well-organized requirement information when you design the database. Instead, it will more like the list of the data, sometimes a bunch of files, or just a discussion. So this is your job to make from this data to such a ER high-level model. Then, next. So, sometimes when you see the attribute, of this one, why don't you take a look at the department? Each department has a name, number, employee who manages. Sometimes I can use number to identify the specific department. Also, we can use the name to identify which department is which. For example, here, so if we have the social security number, it's a 9-digit, but let's say 111, 222, 333, let's say social security number. So using social security number, we can identify specific employee here. At that time, when you can use specific attribute to identify the entity or data or item, that is called key attribute. Okay? So you may get key attribute may be important later. Yes, that's true. So we can identify the key attribute. Here, department, entity, the number is the key attribute. If you believe this is the key attribute, underline. How many? As many as possible. For example, department name can be used for identifier. So we can underline. What about the manager? Manager may not be. So sometimes one manager can manage the multiple. So we are not sure. The start date may be the same. So no. What about the project? Why don't you take a look at the description of this one? Even this description mentioned unique name, unique number. Unique means it can be used for key attribute, name, number. So underline. What else? The employee. We have definitely social security number. As many as possible. Dependent. Name. What if you and me are both employed in the ABC company? Then I have son Nicholas. He has son Nicholas. So it may be the same name. So we cannot use such a name as attribute, key attribute. So sometimes it's okay in ER modeling. Sometimes we have the multiple key attributes. Sometimes we don't have key attribute. So find the key attribute as many as possible. Okay. Later we will select one of them as a primary key. You heard about the word primary key, right? That's the reason it's called primary key. There are many key attributes, but we will select one of them as a primary key. Then also, you will see some of the attributes are multiple value. What about the manager? It's a one manager per department. How many number department? One. What about the location? How many locations? It's a many locations. In case it's a many, okay? Many value. We can double line, double over. It's a multi-valued attribute. Okay? It's a multi-valued attribute. Is there any other multi-valued attribute? Number of hours. One, the one employee may work multiple departments. So 20 hours per week for A project. 10 hours per week B project. The 10 hours per week C project. So it's multi-valued. So you can use the double over for the multiple value. It's a multi-valued attribute. Also, there is another interesting attribute, that is the address. Address can be decomposed to what? Street number, street name, and city name, state name, and zip code. At that time, this is called composite attribute. By combining several attributes, it will be another attribute. At that time, we can use attribute inside attribute, tree structure. So we can use such a tree structure for what? Composite attribute. So this is the.
So you're marking the wrong attribute.
Oh, instead, this will be better. This is the address. This is the SSN. Okay. So composite attribute. Composite attribute means it can be decomposed into sub-attribute. At that time, you can use such a tree structure to represent the composite attribute in ER model. Okay. Any questions so far? This is very straightforward. Everyone can understand. But somebody may be curious. Yes.
Sir, in the employee entity, instead of making another project entity, can't we just relate it to the department? Project?
We will see later. Okay.
Okay.
So that's the next thing we will take care. Okay. And there should be question. Without using this decomposed attribute, okay? Address may be enough, right? 100 University Avenue, the Bridgeport City, and 06604. And we can separate by the street number, street name, the city name. How can we decide which one is better? Which one is correct? How? Always based on requirement, customer request. What does that mean, customer request? So do you remember the first page of a handout? What is that? The left-hand side is application analysis. Right-hand side is the data analysis. So it's always back and forth, back and forth. So if you are not sure whether this is a composite or not, you need to take a look at application. In your program, in your application, whether they need to access separately. So for example, when you sign in any website, so you provide the address information. Sometimes just one text box, address, sometimes street. Address 1, address 2, city name, state name, and zip code separately. Okay? This time, this one is better. This time, this is the better. Okay? Always take a look at it. It's not based on your experience. It should be based on the customer requirement or request. That is the most important thing first time. When you design, you should obey the customer request, customer requirement. Okay? So that is a composite attribute. We almost done half of it, right? The next one is relationship type. As he asked a question, what about the department name? And number of hours is related to project, and also number of project. This should be also multiple project. Okay? Unlike the birth date, DOB, date of birth, these attributes are related. Why? Why don't you take a look at the project description? First, in the department, the first bullet, employee who manage the department. Employee manage the department. Okay, for example, when you take a look at the given data by your customer or your project manager, you will see the lead manage the HR. Patel manage the payroll. John manage the administration department. So what are these? This is an employee. What are these? It's a department entity. Entity do something entity. That's different from the definition of an entity. So it looks like the relationship between two entities. So this is called relationship. So one relationship. By collecting all the relationships, you may realize employee, manage, department. This is called relationship type. Just like the entity, then entity types. Set of entity is an entity type. Set of relationship is what? Relationship type. The next thing is we are going to find such a relationship type. Okay? But as we have done in the entity type, we are going to use relationship type and relationship interchangeably. Actually, relationship is one example. By grouping. Okay? By grouping how? Same relationship manage. So we can find relationship type that is managed. So what kind of the relationship type can you find? In the first bullet, manage. Employee, manage, department. So we can use employee, manage the department. At that time, we are going to use diamond symbol to represent the relationship. Rectangle, entity. Diamond, relationship. Then connect two corresponding relationships. It's a binary relationship, which means one relationship has two entities. So, meaning employee, manage, department. At that time, we don't need this information, right? So it's no longer attribute. It will be relationship. Also, what about the start date? Start date is the start date of this manager, right? So not all employees, not all have such a start date, so we can move start date to the attribute of relationship. So that means relationship can have attribute also. So you can find the relationship, the attribute of the relationship. What else?
So, Professor, one question.
Yes.
So a start date doesn't belong to department anymore.
You can put the start date to the department also. But so more specifically, what kind of information? Manager information, manager information. So that is the reason we can move to here. However, later I will explain why start date can be here, either here or here. No problem. Okay? It's not very important. Later, when we move this one to the database model, you will realize why. Okay, this is the first relationship that we can find. Any other?
First bullet?
In the first bullet, I don't think so, right? What about the second bullet?
Department controls.
Department control. You also realize that italic font represent the relationship type. But this is the first and last example that show the italic or the capital letter. So for your convenience, first because it's the first time. So control, department control, project. Where's the department? Here and project. So we can control we can use this one here. Okay.
Like, do we need to have like arrows to indicate which one controls?
We don't usually use the direction. There is no meaning of the direction. But because it's a small space, I will show you later the better the drawing, because I'm not very good at drawing such a ER diagram or any diagram, but I'm trying my best, but you will see the better quality later. But this is a control. What about the next one? Is there any relationship that you can find? Each employee works for one department, right? Which means employee and department. So let's create here work for. Here, employee. Okay? And what else? Works on several projects. So, works on several projects, right? At that time, we don't need this information, right? That was the reason. We will separate this kind of related attribute and their own attribute. So actually, when you find the attribute from the first step or second step, you can find the only attribute that describes the corresponding entity only. Okay? Later, some related information will be relationship. Anything else? Also, we keep track of number of hours. So, number of hours can be attribute of the work zone. So, we don't need this. It's clear for each project number of hours. Okay? What else? Direct supervisor of each employee. What does that mean? One employee supervises other employees, right? All of them are employees. But there are supervisor employees, there are supervisee employees. That makes sense. Think about the company. In the company, it looks like the tree structure. The top of the tree is a CEO. CEO supervises executive member. One executive member supervises the manager. One manager supervises the other member of your employee. Okay? How can we represent this? This time we have only employee. Employee supervises employee. Is it one? So what different kind of employee? So let's see. For example, lead supervise the part-time. Lead supervise John. John supervise the Smith. Employee supervise employee. What is the relationship here? Supervise. So we can create supervise. How to connect? Employee, supervise, employee. Like that. It's called recursive. The recursive relationship. It may be possible. Then you can understand employee, supervise, employee. It's still binary relationship. That's all. Oh, we have one more. Each employee have the dependent. That's it. 99% done. That's all the thing of the ER model. It's too simple. But before that, is there any question when we determine the relationship type, which is not applied to ER diagram? That's mentioned in this description, but not applied to here. Why don't you read? One who can find such a missing part will give the extra point. Yes?
Identifying relationship.
Identifying relationship. We identify the relationship. Weak entity, that's the next step. I think she study hard, the preview, the section, but not weak entity. From the weak are the relationship. Dependent.
Unemployed relationship.
Employed has the dependent, so we have a relationship. Why don't you read the description carefully regarding to the relationship? No? Sometimes you can see singular. Sometimes you can see plural. For example, unemployed manage the department, which means one employee managed one department.
Each employee.
But what about the next one? Each department, which means one department controls a number of projects, many departments. The project, right? That's different. One employee managed one department. One department controls many projects. What about the next one? Works for. One employee works for one department. Usually we don't say the one department, just on, but it's clearly mentioned it's one department. What many, what several. Okay? That means, why don't we go back to elementary math? So when you learn the set theory, I mentioned many times the set theory, importance of the set theory in math, in this data model. Why? Because our main idea of a relational model, database model, is group of data. So we use the set. When you learn the set, do you remember? This kind of thing. What is this? So mapping. What kind of mapping is this?
One-to-one.
This is a one-to-one mapping. Also, we have many to one, one to many.
One to many.
It's a one to many. Many elements are mapped to one, and vice versa. Many to one. And this one is many to many. So there are three different types of mapping. One to many, or many to one. And also many to many relationship. That should be reflected in this model. Okay? That's different. Okay? So, for example, manage. What about the manage? Is it one-to-one, one-to-many, many-to-many? It's a one-to-one. One employee manage one department. At that time, we will use entity, relationship, one-to-one. So we specify the cardinality. It's called the cardinality. Cardinality of the relationship. One-to-one. Or one-to-many, many-to-one, or many-to-many. What else? Control. Is it one-to-one, one-to-many, many-to-many? It's clearly mentioned in the description. One department controls many. So one department controls many projects. What else? The works on. Employee works on project. Is it one-to-one, one-to-many, many-to-many? It's a many-to-many. Why? One employee works on many projects. One project has many employees. So it's a many-to-many. And what about the supervisor?
One to many employees.
So one supervisor has many supervisees. So it's a one to many. Employee,
One to many.
many dependent. Works on many employees. Okay? So this is a cardinality. So it's a 99.5%. It's done. Okay. So this is called constraint on relationship. So number 5, step 5, is a constraint on the relationship. One more thing. What about the dependent? This is the only entity that does not have key attributes. In the database, it's very important to have a key. Why? Our goal of database is to access the data very fast, especially in the very large database. Without key, it's very hard, right? So we need something key in this example, but dependent does not. So we are going to make the key on purpose. So here, in case if we have the entity that does not have the key attribute, that is called weak entity. All the others are called strong entity. So our goal is to make the weak entity to the strong entity. At that time, weak entity can be represented by double rectangle. Double rectangle means weak entity, which means there is no the key attribute. However, there might be the candidate that can be the key. Name. Name may be used but may be duplicated, conflict. This is called partial key. So how can we make the partial key to the full key? If we know employee information, like we have Nicholas of me. He has a son, Nicholas, as a son, as a dependent. But if we know my name, if you know my employee ID, then Professor Lee's the son, Nicholas. His son, Nicholas. We can identify. Because employee information, employee ID, employee name is not the key. In this case, social security number is the key. 111, the son. 111, Nicholas. Then we can make the unique key. So, which means, why don't we borrow the key of this one, employee? Then, at the time, we can use double diamond. Then, double line to the connector. So, double line and double diamond, double relationship mean identifying relationship. Using the identifying relationship, you can identify the specific entity of weak entity. For example, social security number plus name of dependent. That is the key. Later, we will use that one to create the database. So this time, this is the weak entity. Also, this relationship is called identifying relationship. So in other words, when you identify the specific dependent, you need to use the double line, double rectangle, and borrow the key of this one. Then social security number plus name will be key attribute. One more thing, which is not in this case. For example, just in case, name plus number is the key of the department. That may be possible. That is called composite key attribute, which means name plus number. At this time, to differentiate multiple key, you need to connect, like this one. So when you connect the two attributes, that means it's a composite key. Okay, that's different from this. If not connected, that means one key attribute, another key attribute. If connected, it's a composite key attribute. That's it. Any question?
Can can you explain the weak entity and weak attribute again?
Okay, one more time. So this is the only entity that does not have key attributes. So we intentionally, on purpose, make it strong entity. How can you recognize the specific dependent? With your file, with your employee. So why don't you take a look at the employee? So this time this is called identifying relationship. To differentiate from other relationship, we can use double diamond and double line. This is called identifying relationship. Then using this one, then borrow the key of this, then use key plus this partial key. Social security number plus name should be the key of weak entity. Okay, that is a weak entity. That's it. Very simple. That is the benefit of using ER modeling. So that is the reason. So just less than an hour, we can understand the concept of ER modeling. Really. So it's used in many of the real life projects. However, in the real life project, as I said, this will be your first and last the example of the database description. I clearly describe each and every the explanation. Also, I highlight the entity and the relationship so you can easily find such a thing. But in real life system, you may see such a bunch of number and data. So from that data, you should be able to find the entity relationship. In other words, the domain knowledge is very important. For example, if you are going to design a financial database, the company, you should know about that company, how money is flow and how the system is organized, how HR is organized. If you build a science database, you should know how DNA and genome is organized. Okay, so domain expertise is more important. Most of the company are based on the finance, the money, right? It's a commercial company. That is the reason the understanding, the accounting, understanding some business logic is very important for such a high-level design. It is true in the real-life project. Are you going to have a chance to design? Some of you, but most of the real-life project, they hire the professional accounting or consultant who are not in computer science. Sometimes some of the designers, they don't know anything about computer. However, they can model based on their knowledge. That's also important. So that's the reason not only I emphasize on the importance of the domain knowledge, not only just the programming skill or the programming, the languages, but also you should know the domain expertise, especially money flow and how company is organized. Okay, so let's quickly look at the slide because my drawing is not so good. So we will see. So we already see the simple. Simple is this one. The single or over composite is this. Multivalued is the location. We will see later why we identify the multivalued attribute. Answer is, anyone who knows the answer? Why we differentiate locations and location?
Maybe because when you specify the type, you need to say, I don't know, single line of code or multiple line of codes.
Close.
In project is only one location, so we can include it in a one table. But for department, we can't make another entry for the department as yet on a different location.
I think he answered correctly, which means eventually we are going to use what kind of database? Relational database model, and such as Oracle, Informatics, MySQL, SQL Server, right? Unfortunately, relational database cannot have multi-value in one column. For example, if we use object-oriented database management system, we don't have to worry about such a multi-value. We can define location as the object. We can put as many values as possible, no problem. Unfortunately, relational databases are not very flexible. It can keep only single value, always the single value. Somebody may be curious. What if we why don't we use comma? The New York comma, LA comma, something comma. That doesn't mean it's a multi-value. It's a single value still. You need to process later. So that's the one of the main problem of using the relational database. Also because of that restriction, we can quickly access the data. That's true. Okay? It's a kind of trade-off. Okay? So this is the example of the composite attribute. What about the street address? It can be decomposed. On another level, we can use such a tree structure. So entity type, and also we identify the key attribute and underline. When you underline, if that is a composite key attribute, it should be connected. Many of the students overlook the connected or the disconnected. Entity set, we have found that. Okay. So this is the ER diagram notation. Is this general? No, unfortunately, there is no standard. Okay, this is one of the way to represent. In your first exercise lab, using Orwin software. Orwin is one of the popular modeling tool. Okay, you can easily draw it. Instead of drawing such a horribly, you can just drag and drop and nicely draw the diagram. At the time, some of the tool, there are options, whether we use crow foot type. Crow foot means it's a crow, bird, the foot. So we can use something crow foot type, the diagram, which is also popular. Employee, department, this is a many to one, something like that. And also, UML diagram can be used. We will see the example of UML, but this is one of the popular ER diagram notation. So don't be surprised when you see different types of notation. Ideas are the same. Okay? So in this textbook, they use this kind of notation. Okay? So this is an example of the car entity type. How many keys can you find here? 2 keys, registration or implied. So it's not the composite. As you can see, actually the original data is like this. From this, you should be able to model such a car entity type. So we find this is the first and second step, right? So sometimes you cannot see some of the information like here the department or project is not here because that are related to the other entity that can be addressed in the relationship type. Okay, so relationship type, as we have seen before, so many to one. Okay, it's a many to many, and one to one is a relationship cardinality. So we need to find such a relationship cardinality as many as possible. So this is the same as this one. Okay, but nicely draw. You should be able to. So recursive relationship is a supervisor. It's sometimes called a self-reference. It's nothing but employee, supervisor, employee. Then same employee and come together, then we can get such a thing. Okay. So this is our final output. There should be a missing part. Which one is not discussed in this example? Which one? Derived attribute. She's so good. You studied hard yesterday, right? No, you already know. This is the dot over. What does that mean? It's a derived attribute. Actually, it's not discussed here, but when you take a look at the application analysis, it accesses the number of employees in the department a lot. However, even though you do not have such an attribute, you can calculate. By accessing the department and using the works for, you can find the number of employees. It takes a long time. Okay? Because you need to group the data. So why don't we make another attribute? Okay, for efficient processing. That is the reason you need to always think about application analysis as well as data analysis. So because of the application analysis, we need the number of employees. That's not actually describe the department. Instead, you can derive, you can calculate the value. Another thing, when you use the derive, you need to frequently update. Okay? Employee may not change it every time, every second. Periodically change. However, balance, if you put the balance, the total balance, so I don't think that's a good idea. Balance should be sum every time, real time. Hey, any other? I think that's pretty much. Oh, there's one missing part also. Double line and single line. I explained the double line of the dependent. This is identifying relationship. Identifying, so you can use this identifying table to get the key SSN with the name to make the strong entity, right? What about this? This. Anyone?
Many to many.
Many to many? Not always a many to many. Oh, but here it's just the problem of the generalization. It's just one case. I'm sorry, that's not the answer. Sometimes you have, sometimes not. Double line means
Both the entities are weak. When both the entities are weak entities.
I don't think so. Identify. It's a mandatory participation. Which means, what about the manager? Not all employees are manager. Some of them are manager, some of them are not. Like the this. Manager, but there's other employee who are not manager. It's a mandatory? No, it's a partial, optional participation. At that time, it's a single line. But in terms of the department, all departments must have to have manager. It's a mandatory participation. That is double line. What about the works for? All employees should have the department where he or she works for, right? Double line. At least one employee. Who? Manager. Right? So it's mandatory. Same thing. For example, project. Sometimes department may not have, HR does not have any project. However, project A should be controlled by a certain department. So this is the mandatory participation. This is the optional. So single line is the optional participation. Double line means mandatory. What about this one? Definitely mandatory participation. It's not possible. It doesn't make sense. There's a dependent who is not in the company, right? So that is the reason it's a double line. On the other hand, employee, there might be employees who do not have any dependent. Yes?
You have M and N there. What do they stand for?
Many. Just many. Another many. M-A-N-Y. So M-N, I don't know why. But usually we use M or N to represent many. One means one. Okay. I don't know, I never think of it. It's the next, right? From the N. Okay? Like the XYZ variable. STD and STU, the variable. Any question? Okay, so far so good?
So,
Yes?
can we represent weak entity with the key attribute?
That's also possible. Question is, during the design, so if we know, if customer agree, then you can put name of employee, okay, like that. However, this name should exist on the employee, right? But if you use just without this one, if you use this one, there might be possibility. Name is the Obama, who is not employed. Okay, that is the reason in the first step I recommend to use the weak entity to clarify the purpose of high-level design. Okay, also that may be possible. Any other question? Okay, so that is a weak entity, and this is a final output of the company ER diagram for the company database. Okay, is there any other notation? Yes, we have. For example, in this notation, I'd like to specify each department should have at least 4 employees: manager, the sub-manager, and the 2 other secretary. But in this notation, one-to-many notation, we can use only one or many. Right? What's optional or mandatory participation? We cannot specify the details. So to address that problem, there is another notation. It's a min-max notation. Minimum 4 employees. Maximum no limitation. Or minimum 1 employee, maximum 1,000 employees. So you can specify minimum and maximum notation using min-max notation. So for example, instead of the many to one relationship, 0, 1. 0 is the minimum, 1 is the maximum. Of what? Manager. Employee. Each employee can manage 0 department minimum. Maximum 1 department. In other words, it's optional. Right? It can be 0. What about the department? Department is managed by minimum 1, maximum 1, which means it's mandatory. We don't have to use a double line. Just minimum and maximum. What does that mean? For employee, minimum 1 working department, maximum 1 working department, which means it's mandatory. What about this department? Each department should have minimum 1, maximum the unlimited. If you want at least 4 the employee, you can specify such a thing. So min-max notation is in more details information about your model. So if we convert such a min-max notation like this one. So for example, here in the project, how many employees? Minimum 1, maximum n. And here, department, minimum 4, maximum. Some more details than the one-to-many notation. This is our diagram, but we can use another notation like for example, UML. If we adapt the UML diagram, it looks like this one. Some of you guys are familiar with the UML. So in your project, for the ER diagram, you can use the min-max notation, you can use the growth notation, or you can use the UML notation. It doesn't matter as long as you keep the consistency. Okay. What if so far our relationship has the 2 entities? Employee works for department, 2 entities. Even though employee, supervisor, employee is a 2 entity. Sometimes we may have more than 2 entities in one relationship. For example, this one, we have the supply relationship. This supply relationship is there is a supplier. This supplier supply the part A to the project. So total 3 the entities are combined. So this time this is called ternary relationship. It may be possible 4, 5, 6. So in general it's called n-ary relationship, like the n-ary relationship. Okay. However, it can be understood by, because it's a little bit hard to imagine what does that mean. So supplier supply, we don't know which supply, which part, but project, one binary. Also, supplier can supply specific part, another binary. And part use the project the project use a specific part. So you can decompose ternary relationship into 3 binary relationship. Or sometimes, what if we create the entity? It's a supply entity. So supplier, supply. Okay, join this supply entity. And project is supplied by this supply. Kind of think of a contract. This is a contract entity. So supplier join this contract, project use this contract, and this contract used as the part. So we can have 3 binary relationship with this one. So mostly in real life project, instead of a ternary relationship with life, but this one. Why? Later, when we build a database cannot handle this ternary relationship. Instead, always binary. Some of you guys heard about the foreign key. Anyone who heard about the foreign key? Foreign key is the between 2 tables, not 3 tables. Very, very complicated. So instead, even though in the high level model, ER model, yes, it's okay to find this one, to design this way, but it can be converted either this one or this way. Problem? Are they identical? It's the same meaning? One. This A and B and C, they are the same or different? It looks like the same, right? But it's not exactly the same. For example, there is a part that can be supplied by the supplier, A, B, C, D, E part. But project use only 3 of them. Okay? What about D and E? Actually, D and E are not possible in this case. Sometimes unused data can be available in this. It's more flexible. This is the same. Supply this contract may have any part, but project need only specific part. That cannot be restricted. So this and this are more flexible. Okay, so you should be careful. If we want to apply very strict the policy, you need to add more constraint if we want to keep this one. Okay. So that is a ternary relationship. This is another example. So usually happen in the university database. Instructor offer the course in the specific semester. It can be to address that problem. Sometimes we create the binary relationship and ternary relationship all together, but this ternary relationship cannot be handled in the database system. Eventually, we will use this binary relationship. Okay. This is another example of the university database. This is your homework. First homework. There are a lot of homework over the weekend because you have a very long vacation. We do not have a class on Labor Day. Okay? Labor Day, first week of Monday on September is always the holiday, so we do not have a class on Monday instead of Wednesday. So we have a very long week, the holiday. So first, why don't you see the handout? There is a description about university over here. I think the first page. Okay, university is organized into college and so on. Okay, so answer is behind, but I trust all of you. Without taking a look at the answer, why don't you first try, then draw the diagram. Okay, if you want to, you can do that, just in case you stop. Okay. But if you just copy this one, it's a waste of your time. Believe me. Okay? It's not huge grading. Okay? So this homework will be applied to your final, but it's a small portion. The main purpose is your practice. So why don't you try to draw? Okay? It's not for score, it's not for grading. just for your practice. And in case you stop, then why don't you take a look at this one. There's another university database. This is not completed yet because we will have another event, so you don't have to worry about this one. Then, so that's the first homework. So you can use any notation. If you want to, you can use the UML notation. You can use the one-to-many and with the double line or the min-max notation. Okay, this is the second homework. So this is the ER diagram for banking database. So why don't you take a look at this one? There's an entity bank. It has a bank code, and this is a mandatory participation one-to-many, which means the one bank has many bank branches, and which is identified the branch number. Each bank branch has a account and the loan entity, and there's many account and many loan account, and so on. Using first, you should be able to understand, read, interpret this ER diagram. Then answer the question. How many questions? It's a 6 question. The list the strong entity from the ER diagram, and the answer these 6 questions. That is the second homework. Okay. The others, it's okay. Then how many more minutes?
5 more minutes.
5 more minutes is enough. Test. Quiz. Three of you. And is there any leftover? No? The 3 behind? I think I need to make sure whether I have enough copy. I have only 20 students. Is there anyone who do not register the course? Just audit the course? Or from the distance learning? All of you guys register? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 20. Is there any leftover? I print out the 22 copies. Any leftover? No? That means it will be another homework. Okay? So it will be another homework. How many more copies? I will upload the PDF file to the Canvas. Okay? Then you can download and print out. So, but, yes. So I will upload to the Canvas. But I don't think you can solve all these problems because there are missing parts as much as possible. Okay? Why don't you try to solve the problem, especially for the library part. Library, the main and branch. So sometimes you cannot address the whole problem. So why don't you try to do your best? Okay, this is the third homework. So do not submit this homework to the Canvas. Okay, instead bring your hard copy. So first homework is university database. Second homework, the bank database. Third homework is the library. So you are going to practice already 3, the database modeling. In your project, if you select this kind of database, that will be rejected. So these are the 2 simple. Okay. Some of the team already the request to make the university or library will be rejected. Why don't you think about and still not too late to inform? Why don't you inform to the? There's one more. The fourth homework. Even I need to download. In addition to this one, it doesn't take a time. Okay, that takes a long time. One more thing is why don't you find any? Okay, it's from internet or other textbook, not our textbook. You can find. Why don't you find the example of the database that can be modeled? So why don't you find it? So you can search the other university database class or the exam or whatever. So, but that's not bank, that's not university, that's not company. Why don't you find the description? Okay? Then try to solve that problem by yourself. So, if I ask such a homework, some of the students bring the 10 pages long description. It's too long. Less than half, the 2/3 of the letter size. Okay? So please bring the, you need to submit that description. Okay? With the solution. PDF version or the Microsoft Word. I'm going to create that last homework on Canvas. So first 3 homework you need to submit in the next class on Wednesday. And the 4th homework, why don't you find, for example, the detailed database. So description is the half page, then this is my answer. Then the reason why we are doing this homework is I'm going to collect all the database and put together, then hand out. Then you guys will have the more experience on the database.
So we have 4 homework,
Yes, 4 homeworks.
and the last homework is due when?
So by next week, the 1 week. It's not, it doesn't take a long time. Okay? So I will email you by summarizing the homework. So 1 to 3 is you can submit, hand in the next class. The last one, why don't you find the description, project description, then your answer. Then I will share with other students the sample database. Yes?
So sorry, can you give us like an example of concepts that I can see?
So it can be, for example, the game database. It can be ticketing database. It can be any kind of database. You don't have to create the new database. Instead, find, search the Google or other textbook, anything. You can find it easily. Okay? Example of or you can type retail database or movie ticket database. It's not too complicated, but just a simple for your practice.
This is not phase 1, this is a whole different.
Oh, no, it's a different. Okay? Then I'm going to use some of the example for your exam to make me easy to make the question. Okay? So I will select some of the example of the database. Okay, thanks so much, and have a nice weekend, holiday, and we will see you on Wednesday.